Alright guys, this is going to be the final video on the second review packet. So we're going to be really focusing on integrals here, and in question 9 we're evaluating definite and indefinite integrals. So in letter A, this is a definite integral because I can see the bounds of integration here, and I'm asked to simplify my answer as well. So I am going to make a u substitution because we have a composition going on here. This is a square root function, and then within that square root function I see a linear function. So I'm going to let u equals z minus 1, and in that case du is going to equal dz, 1 dz, right, because the derivative of z minus 1 would be dz. Okay, so then I can make a substitution there, and I can rewrite this integral as the integral from something to something, we have to figure that out, of the square root of u du. So let's find the new bounds of integration here. If z is equal to 1, then u is equal to 1 minus 1, which is 0. Okay? And if z equals 10, then u is equal to 10 minus 1, which is 9. Alright, so now we can just evaluate this integral right here. The antiderivative of the square root of u, or the antiderivative of u to the 1/2, is going to be u to the 3/2 times 2/3. And we're evaluating that from 0 to 9. So this just means take 2/3 of 9 to the 3/2 minus 2/3 of 0 to the 3/2. And 0 to the 3/2 times 2/3, that's going to be 0. So what is 9 to the 3/2? It's probably better if we think of this in terms of square roots. So this is going to be the square root of 9 cubed times 2 divided by 3. So the square root of 9 is 3, and 3 to the 3rd power is 27. 27 divided by 3 is going to be 9, and 2 times 9 is 18. Okay, letter B. This is an indefinite integral because I don't see any bounds for integration, so I'm going to have to remember to account for any constant value that might exist. And when I begin evaluating this, I'm looking for any compositions we have. I see a 1 over x function here, a rational function, and within that, a cosine function to the 4th power. So what I'm going to do is let u equal cosine of x, because that's the innermost function there. And in that case, du is going to equal negative sine of x dx. Now I don't need that negative, so really I'm just going to say that negative du is equal to sine of x dx, because these two things are both components of the original function that I want to make sure I account for, and then I've got the cosine that I need there as well. So now I can rewrite this integral as the indefinite integral of 1 over u to the 4th, because that cosine is being raised to the 4th power, times du, and don't forget there is a negative involved, and I'll put that on the outside. So now I need to take the antiderivative of u to the negative 4th, right? Remember that that's how I could rewrite that. So I need to elevate that exponent by 1. So negative u to the negative 3rd divided by negative 3, or times negative 1/3 if you'd rather do that, plus c. And so now I'm going to make my substitution and put the cosine back where it used to be. So actually, before I do that, I should rewrite this as 1 over negative 3 times u to the 3rd, remembering that that u with the negative exponent goes to the denominator. And in doing that, I don't need these negatives anymore, because a negative divided by a negative is a positive. So now I can replace u with cosine and say 1 over 3 times cosine cubed of x plus c. All right, example C, another indefinite integral, and we've got a product here. We don't want that, so I'm going to bring this square root of x into the parentheses here by multiplying, and remember that that is an x to the 1/2 power. So when I distribute and rewrite this, I'm going to have the integral of x to the 1/2, because x to the 1/2 times 1 is x to the 1/2, and then I have x to the 1/2 times x to the first, so I'm going to add those exponents, x to the 3/2. So I'm rewriting the function, and now it's clear that all this is just me reversing the power rule on each of these terms. So I'm going to elevate the exponent by 1 and make sure that I account for the coefficient that each of these variables needs to cancel them out. And then I have x to the 5/2 times 2/5. Don't forget that there is a plus c there. You don't need to simplify this, so you can just leave that one the way it is. And finally, example D. So this is going to definitely require a u substitution because the composition that I'm looking at is an e to the power of something, and that something is x squared. So I'm going to let u equal x squared, which means that du is equal to 2x dx. So the question is, do I need all of these things? I definitely need the dx. I need the x for sure. I don't need that 2, so I'm going to rewrite this as 1/2 du is equal to x dx. And now I have only the two things that I need over here. So now I can rewrite this, but before I do that, I should consider that the bounds are going to change. So if u is equal to x squared, and x is equal to 0, then u is equal to 0 squared, so u is 0. And if x is equal to 2, that's a 2, then u is equal to 4. So I can rewrite my integral as the integral from 0 to 4 of e to the u power times, well, du, and don't forget that we have a constant 1/2 there that needs to be substituted as well. So now I can take the antiderivative of e to the u, 1/2 times, that's just going to be e to the u, and I'm evaluating that from 0 to 4. Okay, so this is going to be 1/2 times e to the 4th minus e to the 0, and e to the 0 is just going to be 1. So I'm going to rewrite this as e to the 4th minus 1 over 2. All right, example 10 is actually pretty quick as long as we apply the fundamental theorem of calculus correctly here. So if you've been told that h of x is a function, and part of that function is an integral, then you want to look at the bounds of integration and make sure that the top bound, if that's a variable, we can very quickly go to h prime of x. So I can say immediately from this that h prime of x is equal to x times sine squared of x. And that's it. That's the derivative function. Now there's a previous video from the first review packet. If you want to take a look at that one, I go through a little bit slower how we get there. But hopefully in taking the exam, you go straight to this point where if the function is containing an integral and part of that integral is a variable, then you can go right to this point. Just make sure that your top bound is the variable. If it's the bottom bound, then you'll want to flip them and negate the integral. So anyway, at this point, now we can just plug in the value that we're asked to evaluate this function for. And so we're asked to find h prime of pi over 4. And so that's just going to be pi over 4 times sine squared of pi over 4. So now we have to remember from the unit circle, pi over 4 times, well, sine of pi over 4 is radical 2 over 2, and we are squaring that. So that's going to be pi times 2 over 4 times 4. All right, so that's 2 pi over 16, or pi over 8. And that is as simple as that. All right, so if you do want to see a longer explanation of how we go from h of x to h prime of x in this case, take a look at the video from the first review packet that discusses integrals as well. All right, and that does it. That's it, the very last problem in the review packet. So I'm going to post the answer keys on paper to those, and good luck studying for the exam tomorrow, guys.